Hey guys, welcome to the Level 2 2020 Algebra NZQA exam paper. So how this video works is that I go through each question and tell you guys what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I went about getting the answers. So without further ado, let's get started. All right, guys, so let's go with question one here. Now, what I'm going to show you guys with question one is I'm going to show you guys both methods. Well, actually, there's more than two methods, but I'm going to show you guys the shortcut using the graphics calculator, but I'm also going to show you guys how to do it the long method. Now, this is something that you might remember from last year. So first off, I'm going to go through with the long method, and then I'll show you guys the shortcut as well. So the way I go about it is negative 15 times 6. So that is, what do we got? 30, negative 90. So I'm basically looking for two numbers that multiply to negative 90 and add up to 13. So in this case, I know that it's going to be, what do we got? 18 and 5? Yeah, 18 and 5 seems to work. So I'm going to have 18 and negative 5 and 18 and negative 5, which adds up to positive 13. So all I'm really doing is I'm going to replace this 13 with 18 and negative 5. So when I do this, I'm going to end up with 6x squared plus 18x minus 5x minus 15. And at this point, I need to factorize by parts. So I'm going to factorize the first two elements there, which has got 6x and x plus 3. And as for the second part, I can see minus 5 is a common factor. So I'm going to get x plus 3. So at this point, I can kind of see that x plus 3 is a common factor, and I'm left over with 6x minus 5. So as you can see, 6x is coming from there and negative 5 from there. So this question is worth an achieved. So how do we do this in the calculator? Now in the calculator, it's a little bit, how do I say it? It's not tricky or anything. It's just understanding how the solutions work, and then you can kind of work backwards in it. So what I'm going to do is I'm going to go down to equation, and I'm going to go into polynomial, degree 2, and I'm just going to enter my values of 6, 13, and negative 15. That is from the coefficients. So if you guys have a look at it, there's my 6, 13, and negative 15. I'll put that in, and I click on solve. So when I click on solve, I end up with two answers there. I've got 0.833 and negative 3. All right, and this is where it's kind of useful to use this number here, so 5 over 6. So let me show you what I mean by. So the solution for this is we've got x equals to 5 over 6, or x equals to minus 3. So all I'm going to do is I'm going to rearrange it into into a bracket that equals to 0. So in my first instant, I can actually see that x plus 3 is equal to 0. All right, and in the other instant, I'm going to take care of the 6 first, so it's going to be 6x is equal to 5. And then rearrange it, so I'm going to get 6x minus 5 is equal to 0. Now, be very careful in doing this method, because sometimes you might not end up with x, like I'm particularly looking at here. So some other situations, you might have something like, how am I saying this? Actually, no, I'll tell you what. The best way to do it is put those two brackets, put those two solutions. So where we got that and that, which is 6x minus 5 and x plus 3. Now, the reason I said just double check that it works out is if you quickly just look at that value there. So 6x times x is 6x squared, and then negative 5 times 3 is negative 15. So you're on the right track. So that's another way you could do it as well. So it still gets you an achieve. And the only reason I said be careful with doing the graphics calculator method is sometimes you might get a factor that looks like this. 2x plus 4 is equal to 0. And if that happens, then remember that your solution is going to actually look like this. X equals negative 4 over 2, x equals to minus 2, for example. So in this case, when I rearrange it, I'm actually going to get x plus 2 equals to 0. So that's why it's always a good idea to go back and check once you factorize it that those numbers actually multiply to the original equation. Okay, enough talk for an achieved question. We are moving on to the next question here. So question 2, what we have got here is we've got this function, blah, blah, blah. We've asked to complete the square in this. All right. So what we're going to do is we've got x squared plus 10x plus 22. So for completing the square, all you have to do is take the coefficient of x, you divide it by 2, and then you've just got to square the number and add and subtract. So let me show you guys what I'm going to do here. So I'm going to take that 10. So 10 divided by 2 is 5, and then 5 squared is equal to 25. Cool. So what I'm going to do now is I'm going to split that 10x. Actually, no, I'm not going to split that 10x. I'm going to leave the 10x as it is, but I'm going to add 25 to it. All right. Actually, let me show you another method. Maybe this might actually make sense. So I'm going to leave the 22 at the end there. All right. Because I want to complete the square, I am going to add 25. Now, I can't just add a number in a statement because that's not keeping it the same. So if I add 25, I've got to remember that I've also got to take away 25. Ideally, what I'm written in that first line and the second line is the same thing, except the blue part is actually worth 0 because 25 minus 25 is 0. Now what I'm going to do is I'm going to factorize just this part here because that is going to be a nice square number. So that's going to factorize into x plus 5 and x plus 5. And I've got negative 25 plus 22 equals negative 3. So now I can actually rewrite this as x plus 5 squared minus 3. That's pretty much how you do this question here. So this is actually worth achieved as well, I believe. Yep. And the question you might be thinking is this possible in the calculator? Let me just have a play with it, and if it is, I'm going to show you in this next one. Otherwise, we move on to the next question. Yeah, no luck with that. I might have to do a little bit more digging on that one to see if that's possible. But anyway, we move on to the next question. Okay, so question C1. Lots and lots of writing here. What have we got? So mathematicians, blah, 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 cubic equation, passes through 440. Find an expression for P in terms of R. Okay, so what we do know is that we've actually got the equation here. I'm going to need this space. Okay, so I'm going to write this equation down, which is x cubed minus 12px plus r. Now they want P in terms of R, and they also let us know that it goes through the point 440. So all we're going to do is we're going to substitute 4 and 40 wherever x and y is. So we're going to get 40 is equal to 4 cubed minus 12 times P times 4 plus R. So we actually have 40 is equal to 64 minus 48P plus R. And I'm going to bring the 48P to the left-hand side. So it's going to become positive 48P equals 64 plus R. And of course, I'm going to switch over the 40 to the right-hand side, which makes it a minus 40. And so what I'm left with is 48P equals 24 plus R. Now it's really important that I need to have P by itself. So P is equal to 24 plus R divided by 48. So grades-wise, substituting correctly gets you an achieved. Substituting correctly gets you an achieved. Wow. So basically just here. Looks like it. Find an equivalent. So P in terms of R is actually getting you a merit grade there. Cool. That's it for C1. Let's go to C2. So question C2, what we've got is we've got point B. It's true that 3x squared, blah, blah, blah. They're asking using show x. Okay, so all we're really doing here is just rearranging things and then justifying it. So what we've got here is we've got 3x squared minus 12p equals to 0. So when we rearrange this, we're going to get 3x squared is equal to positive 12p And then I'm going to get rid of that 3. So I'm going to get 12p divided by 3. And I end up with x squared is equal to 4p. Now, when I take square root of x here, I'm going to get square root of 4p, but remember that it's going to be plus or minus. So x is equal to plus or minus. Now square root of 4 is 2, and square root of p is, remember that square root of a number could be written as to the power of half, or 0.5. So in this case, we're going to get x is equal to plus or minus 2 p to the power of 0.5. However, we're not done here. And the reason we're not done here is because if you look at the original question, it actually says, it gives you a hint. Show that x is equal to negative 2p, 0.5, right? So if you actually go back to the graph. Now we've actually got two values for x. So our first value is positive 2p 0.5, and then our second value is negative 2p to the power of 0.5. Now, any number to the power of 0.5 is always going to be a positive number, right? So that means this right here is always going to be positive, because we've got p to the power of 0.5 is positive. Positive times positive 2 is going to be positive. However, in this case, because p to the power of 0.5 is positive, and when we multiply it by negative 2, we are going to get a negative number. So as you guys can see, there's two values for x. X can be a positive number or x can be a negative number. But we are only focused at the point B. So if I go back to my diagram, my original diagram, you can see that B is here. And when B is there, x has to be a negative value. It can't be a positive value. So we're going to go back here and we're going to write a little statement and say that point B has a negative x value. Therefore, x is equal to minus 2p to the power of 0.5. So grades wise, you have to give this explanation to get an excellence grade. Up to a merit, you're looking at here, and then for achieved, you could get achieved here. You could get achieved here, and all of that is achieved. But to get that merit, you got to have plus or minus p to the power of 0.5. Yeah, so it's not bad of an excellence question, to be honest. Like, it's, yeah, I thought it'd be a little bit more challenging than that, but that's what we're working with. Cool. So let's go to the next question. Yeah, I remember having a look at this question and going, geez, that's a lot of reading to do. I'm going to try and zoom in as much as I can. And hopefully you guys can actually grab it. I'll try and work on the side there, but at this point, I definitely recommend you guys to pause the video and read through this question, all right? Because this is just one of those really long questions. All right, guys, I hope you had a chance to actually read through this question. But basically, what we're asked to do is to find out when is that orange line, or like for what values of p will, in terms of r, is that orange line going to be bigger than the blue line? Because think about it like this, all right? So the orange line, let me see if I can pick up here. There we go. So there's your orange line right there. Now we want that orange line to be bigger than the blue line, because if it's bigger than the blue line, then what's going to happen is you're actually going to end up with three points. So as you can see, there's one x value, there's a second x value, and then the third. So it actually cuts the x-axis 3 times. So we need to figure out for what situation is the orange line actually bigger than the blue line. All right. So to do that, first we got to try and figure out what is the length of the orange line. All right. So, and the other part that's actually worth noting is this: the blue line the blue line. What is the length of blue line? I'm gonna have to rub out all of these things, but just to give you guys a bit of an idea of what's happening here. This R right here, that is the length of the blue line. Now think about it like this. If R is equal to 0, then the curve is going to go through 0. Because remember that when you have this equation, y equals x cubed minus 12px plus r, we can see that when x equals to 0, y is equal to r. Therefore, we can say that r is always the y-intercept. So in this case, we can actually see that r is the blue line. So that's something that's actually worth remembering. Now what we're going to do is we're actually going to put another line in here. And I know you're not going to like this, but I'm going to work out point B. What's the y value of point B? Because if I find out the y value of point B, that's going to give me the length of the green line. And of course, using green line minus blue line, I'm going to get the orange line's length, the actual orange line's length. So I'm going to work out what B is first. So sorry, the coordinates of B. So my equation right now is y equals to x cubed minus 12px plus r. So remember that x is equal to this thing right here. So I'm going to substitute it all. So I'm going to get negative 2p to the power of 0.5 cubed minus 12p times x, which happens to be negative 2p 0.5 plus r. And now I've got to work it out. So negative 2 to the power of 3 is going to be negative 8. And then p to the power of 0.5 times 3 is 1.5. Now inside here I've got minus 12 times 2, which is positive 24. And then p to the power of 1 times p to the power of 0.5 is p to the power of 1.5 plus r. Now simplifying this, I'm going to get y is equal to 16p 1.5 plus r. Now what I've really discovered is the coordinate of B, but that also happens to be the length of that green line. So if I think about it like this, coordinate of B right now, so B's coordinate is actually negative 2p to the power of 0.5 and 16p to the power of 1.5 plus r. So that's what that coordinate is. So basically, of course, it doesn't want to work. So what we actually have here is the coordinate of B, right? So which means B value right here. So let me just draw that up. That point right there is going to be 16p to the power of 1.5 plus r. So now what we can say is we can actually figure out what that orange line is. So the orange line is going to be the green line, take away the blue line. So which means I'm going to get the green line is equal to 16p to the power of 1.5 plus r minus the blue line, which happens to be r, which is what we already discussed before. So our orange line is equal to 16p 1.5. So now we want to know for what situation is the orange line actually bigger than the blue line. All right, so we're going to write this up. So we want to know for when is the orange line bigger than the blue line. Now the blue line, we know what it is because that's r. And we also know what orange line is, which is 16p to the power of 1.5. And this is all greater than. All right, so we can rearrange this now. So we're going to get p to the power of 1.5 is greater than r over 16. Now it's really important. Once again, we got to have p on its own. So what we could do is we could actually rewrite this as p to the power of 3 over 2 is greater than r16. Or we can actually rewrite this as p greater than r over 16 to the power of 2/3. Cool. So that's what we're looking at for this particular question. And I know there's a lot of information here, but reality-wise is that if you go right to the bottom of the question, it actually tells you all the clues that's been given there. And it's just a matter of just working through them. So in terms of grades, length of the orange line obtained gives you a merit. So that right there. T1 recognition. So this gets you one. Yeah, it's a bit of a weird one. This, I think I'd actually ask you guys to have a look at it, because basically it seems like you can actually get a E8 from just giving the final answer correctly. Otherwise, you can get an E7 from here, which is an excellence. Or if you do the final step right, you get an E8, which actually gives you the full 8 points for this question. All right, so that's basically question one. Let's move on to question two. All right, so let's go to question 2A. So what we've got is logarithm, and write it in a simple format. All right, so what we've got, we're going to do the two addition part of it first. So when we add, we remember that we've actually got to multiply. So it's going to be 9y times 4 minus log of 3y. So inside my first bracket, I've got log of 36y minus log of 3y. Now when I minus, I've got to divide. So I'm going to get 36y divided by 3y. And of course, this simplifies nicely to log 12. Kicking off with a nice achieved question there. And then we're moving on to question 2b. Okay, so with this one, what we have is we've got to rewrite this first. So, and this formula is actually given to you guys in the formula sheet. So it's just a matter of matching everything up. So when you match it up, what you're going to end up with is x squared is equal to 36. And of course, then you can say x is equal to plus or minus 6. Once again, it gets you a grade of achieved. A couple of really nice achieved questions to kick off events here. Yeah, there's nothing else you could do beyond that, unfortunately. Like, I'm trying to think of, is there something I'll do in the calculator or not? Would I do this in the calculator? Yeah, it just takes too long, really. I mean, you could try it if you're really in doubt. You could do this. So you could go to equation and then go into solver and type it up. So you get like, to do this, what you could do is log 36 divided by log of x, and then that's equal to 2. I don't know if this is going to work. And solve. Yeah, okay, it does work. So there you go, x equals to 6. Another quick way to just check your answer. All right, so let's go to the next question. What about this one here? Pretty much, we're going to do the combination of that, what we did in question A. So this is going to be rewritten as log 5 of x times 2x is equal to 4. So we're going to get log of 5, 2x squared is equal to 4. So we can rewrite this as now 2x squared is equal to 5 to the power of 4, which is 625. And so we've got x squared is equal to 625 divided by 2. So x squared is equal to 312.5. And then just put a square root around that 312.5. So what have we got? Shift that, 312.5. So once again, we're going to, I just realized something else. It's as I'm actually going through it. Now we can't actually do plus or minus in this case. I'll have to go back and readjust that in my previous question. So it's got to be 17.67. Partially, why can't we have plus or minus? Well, partially because like x has to be bigger than 0, because we can't actually find log of a negative number, right? So x has to be bigger than 0, and so that's why x is equal to 17.67. So if I actually go back to my previous question, just realize that that should be a plus there. I'm just going to leave it as a plus right there. Forget about the minus, because you can't actually have Yeah, because you can't actually have a base of a negative number there. It's not going to work with logs. Cool. So what we have next is, let's go back to that other question that we were working on. So we have to say x has to be greater than that. So therefore the solution is 17.68. Grades wise, final answer gets you an excellence. Finds x gets you a merit. Combines logs in a valid way. So that part right there is going to get you an achieved. Yeah, not a bad question. It's just something that you need to remember. See, the thing is, I haven't actually done what level 2 algebra in like, God, almost like 1.5, no, maybe a year, and I seem to forget things. Maybe I need to keep doing these little things to just keep my memory fresh. But anyway, let's go to question C. Oh my goodness gracious. This is just one of those nasty questions, isn't it? I'm just going to pause for a second while I go through this in my head of how to actually do this. Yeah, there's no other way. I think that's just one of those really long questions. It's not even a common factor in the denominator. It's just like a random ass question that they decide to do. I don't even know why they want you guys to do this type. But anyway, this one, we've got to cross multiply. So what we've got here is 5x plus 4 multiplied by 2x plus 1. So I am cross multiplying here. Minus 3x minus 4 multiplied by x plus 4. And the denominator is x plus 4 and 2x plus 1. Now, normally they'd be nice and give you guys like some sort of common factors in the common multiples in the denominator, so you don't have to do this ugly thing. But guess what? This is just one of those really ugly long things that we have to do. So expanding it out, I've got 10x squared plus 5x plus 8x plus 4 minus, I'm going to put this inside a bracket, so 3x squared plus 12x minus 4x minus 16. And the whole thing divided by 2x squared plus x plus 8x plus 4 equals to 2. Simplifying the top of the numerator there, so I've got 10x squared plus 13x plus 4, that's a good start, minus 3x squared plus 8x minus 16. I might as well move that denominator to the other side. So I'm going to get 2 times 2x squared plus 9x plus 4. I need to get out this, what do you call this, negative, out of this. I've got to take the brackets out. So I'm going to get minus 3x squared minus 8x, and then negative and negative 16 makes it positive 16 equals, expand the brackets on this side, 4x squared plus 18x plus 8. Simplifying the left-hand side, I've got 7x squared plus 5x plus 20 equals 4x squared plus 18x plus 8. Rearranging it again, got 7x squared plus 5x plus 20. Let's make that 20. Whoops. So it's gone a bit further, plus 20. And I've got to bring everything back, so it's minus 4x squared minus 18x minus 8. Simplifying this, I've got 3x squared minus 13x plus 12 equals to 0. And I'm out of space. So at this point, you can do the whole factorization, but because the thing is like, I mean, you can actually use the quadratic formula to solve it. But the reality is we've got the graphics calculator, so, we're not going to waste time. If you want to do the quadratic formula, by all means, go for it. You're still going to end up with the same answer. So I've got 3, negative 13, 12, and my two answers are x equals to 3 and x equals to 4/3. So I'm going to write that down. So x equals to 3 or 4/3. And interestingly enough, this question is worth just a merit. And you've got to get both of those answers correct for the merit. For achieved, begin to handle denominators and common denominator multiplying through by one denominator. Okay, so this is just a weird looking achieved. In all honesty, I'm thinking somewhere here you're looking at an achieved. And that's a guess, by the way, because it's like, yeah, it's just weird how they say begins to handle denominators in the schedule. Have a look through the schedule anyway. Cool. So that's question C. Very long little question there for a merit. Okay, let's go to question D. And again, guys, I'm going to ask you guys to pause the video and just have a look through this, just like how I'm going to do as well, and then we'll try and work it out. Okay, so with looking at this question, we've actually got two parabolas, all right? And we're trying to figure out the restrictions of those four A, B, C, D values, and possibly E as well, right? So that the parabolas meet at two distinct points. Now, if you look at parabola 1, it has the same y-intercept as parabola 2. So you can imagine it like this almost. If you have like parabola 1 like this, let's just draw like a quick axis just to show you guys some of the things that could potentially happen. So we could have parabola 1 like this, or we could have parabola 2 like this, but they both have the same C value because they're going to always meet at the y-axis. So you could have like that, or well, that's a terrible one. Or there like this, all right? Doesn't matter. So that first point, we know that the parabola is going to meet is when x equals to 0. So how do we actually do this? So we're going to put parabola 1, which is ax squared plus bx plus c, equals to dx squared plus ex plus c. Now the two c's, they cancel out each other, and what we've got here is 0 on the left-hand side when we move everything from the right-hand side to the left-hand side. So we've got minus dx squared and minus e of x. So simplifying this, we've got ax squared minus dx squared plus bx minus e of x equals to 0. So as you can see, this can be written as a minus dx squared plus b minus e x is equal to 0. Now, if I factorize x, we're taking x as a common factor out, I'm going to get a minus dx plus b minus e is equal to 0. Now, and if you remember, so what we have here is we've got x is equal to 0, or this entire bracket, or a minus dx plus b minus e is equal to 0. So if I rearrange that, I'm going to get a minus dx equals, this becomes negative of b minus e, or in other words, it becomes negative b plus e. And on this side, I've got a minus dx. And so x is equal to e minus b divided by a minus d. So, as I said in the diagram before, first solution is going to be x equals to 0. All right, because they have the same y-intercepts. Now, for the second solution, we got a couple of conditions though. So second solution is e minus b divided by a minus d. But we've got to actually say this, okay? As long as a is not equal to d. Because if a is equal to d, then we're going to have a second solution that doesn't exist. And the reason is because if a equals to d, then this number here becomes 0, and then we can't actually do a letter divided by 0 because that's like doesn't exist. So therefore, a can't be d. And the next thing is you can't also have e cannot be b as well. Because if e equals to b, then your numerator, I'm going to choose a different color here, just trying to figure it out. Your numerator becomes 0. All right, and that means you go back to getting the first solution. And remember, you want to have two distinct solutions. So that's why we actually say that a can't be d and e can't be b. Pretty much that's the constraints for this question. And again, this is one of those double excellence questions. So if you actually end up with the right constraints, you end up with an E8. One of the constraints is E7. But if you do both of the constraints, you actually get E. Solves quadratic correctly but does not draw conclusions. So that's a merit. So that's like up to here. You're looking at a merit when you get the two answers. Setting up a simultaneous equation gets you an achieved. Yeah, strange little double excellence question, but it's just, it's not really asking you to prove any, it's not like one of those classic excellence questions where you're given and solve. This is one of those questions where they're asking you to prove, and I'm wondering, is this the direction that they're going for 2021? But, you never know what they're going to throw us. Hey, anyway, that's it for question 2. We are moving on to question 3. All right, guys, so let's get going with question 3. What we have got here is 3 to the power of 4x equals 30. So I'm going to take logs on both sides. So I'm going to get log of 3 to the power of 4x equals log of 30. 4x can be brought to the front. So I've got 4x log 3 equals log 30. And then 4x is equal to log 30 divided by log 3. And of course, x is equal to log 30 over log 3. And if I want the whole thing divided by 4. So this is what I'm looking at in my calculator. If I can find it, what do we got? Menu 1. So what do we got? Log 30 first. Log 30 divided by log 3. And the whole thing divided by 4. So I've got 0.7740 gets me, oh wow, this actually gets me a merit question. Nice. So that's a merit right there. And then expanded log form gets you an achieved. Couple of gimmies right there, as we say. Moving on to question 2, or B part 2. Okay, so question B1, all they're asking you to do is make x the subject of the formula. Now here's a little trick that I kind of go through in my tutorials. So what I'm going to do is I'm going to rewrite this as x plus 2 to the power of 205 equals w. Because I want to make x the subject, I'm going to leave it here. The next thing is I do the inverse of that power. So what I'm going to do is x plus 2 equals w to the power of 5 over 2. Then x is equal to w to the power of 5 over 2 minus 2. Bam, done. That's my achieved right there. So for those of you guys that have wondered about that reverse thing, if you ever see something like this, x to the power of 7/10 is equal to, I don't know, 8, then you can actually say x is equal to 8 to the power of 10 over 7. All right, it's just something that we can do real quickly. Just to, when we take the powers to the other side, we just flip it upside down. And it just makes sense, really, really fast way of doing this. Cool, that's achieved right there. Let's go to B2. So for what values of x will the function have values less than 20? So we want to know when is this equation, so x plus 2 to the power of 2 over 5. When is it less than 20 is what the question is. So as I said to you before, we're going to do that flippy thingy. So we've got x plus 2 is less than 20 to the power of 5 over 2. And then x is less than 20 to the power of 5 over 2 minus 2. That's pretty much the same thing as what that previous question was. The only thing is we're going to have to do one extra step here, which is actually solve this. So we've got 20 to the power of 5 over 2. So I'm going to make sure I put that in a bracket, because if you don't put that 5 over 2 in a bracket, you're going to get a whole heap of mess. And then minus 2. So because I'll show you guys what happens if you don't put it in a bracket, right? So if I go 20 to the power of 5 over 2, don't know if this will work, but let's see. Sometimes it does and sometimes it does. See, there you go. It's stuffed up this time. So that's the difference of that bracket, all right? So it's really important that you put 5 over 2 in a bracket. So the number we're looking for is 1786.85. 0.85. However, there is a really, really important thing to find out here, all right? And this is just cheeky the way they do this. Like if you go back right to the start of the question, there's something in bold right here, all right? where x is a whole number. All right, so this is something that they do, like they'll put a little part that's bold, but then it comes later on in the question. So right now, we've actually said that x has to be less than 1786.85, but this is not a whole number. So if we're going to put our answer as a whole number, we leave it as x has to be less than 1787, or x has to be less than or equal to 1786. And if we do this last line, we actually end up getting a merit. Otherwise, we are going to stay with an achieved, which kind of sucks, really. So that's why it's really important to have a look at those. If you have a question paper and you've got something in bold, it's really important that it's going to come back later on somewhere. All right, so it's just something to keep in mind. Cool, so that is what a merit question. And then we're going to our last question. Are we going to the last question? No, the second to last question. All right, so looks like a bit of reading to do. Pause the video and then let's have a go. Okay, so hoping you guys have actually had a chance to read this question, but basically what we have got here is we can actually say turnover. Turnover is price multiplied by zips sold. So now what we've got is we want to figure out when is the turnover exactly $445. Now, I shouldn't say price, that should be price. Now the prices equation is 2D plus 5, and the zips sold is 101 minus 3D. So what we have got to do is we've got a quadratic equation. We're going to expand the quadratic, put it equal to 0, and solve it. That's what we're going to do. So we got 445 equals, what have you got? 101, so 202D minus 6D squared plus 505 minus 15D. So we got 445 is equal to minus 6D squared. 202 minus 15 is plus 187. D, and plus 505. So rearranging this, I'm going to put 0 here, minus 60 squared, plus 187D, plus 505, minus 445, and I've got a nice quadratic equation with 187D plus 60. Cool, so I'm going to chuck this in the graphics calculator, and again, you can actually use quadratic formula if you have the time, but because we are allowed to use the graphics calculator, I'm just going to go straight there. So we've got negative 6, 187, and 60. Cool, so when we actually solve this, we're actually getting D as two values. So our first value is 31.48. And then our second value is negative 0.317. Okay, so if we actually go back to the question, and I'm particularly interested in this part here where it says use algebra to justify your answer and explain your conclusions. All right, so the first thing is we actually have to say that D has to be positive. All right, so D has to be positive because, well, we're looking at how many number of days that's there, but it's also got to be a whole number, right? Because we can't really say at 31 days and half a day she makes 445. It kind of doesn't make sense because it's her values that she's looking, like the D that she's looking at is actually, they're actually whole numbers. All right, so it's actually days, total number of days. So there's two problems here. The first problem is that it has to be positive, which means we can't actually have the negative 0.317, but it also has to be a whole number. All right, and if it's a whole number, and again, I'm going back to the question there. If you look at it, is there any day on which the turnover is exactly 445? That's why it's got to be a whole number. So we actually have to say that D has to be positive and a whole number. So neither solution. So neither solution is valid. And which also means she never does 445 in one day. Never makes exactly $445 in a day. So that part is really important as well. So grades wise, this actually gets you an excellence grade right at the bottom, the explanation. If you just find the value of D, that's going to give you a merit. Forms the correct equation for turnover, gets you an achieved. Right there, that's going to get you an achieved. All right, so let's go to the next part of this question. Right, so for this part of this question, we're pretty much going to do what we did in the previous one, except we don't have that 445, and we're going to put a K value. All right, so we don't know what this K value is, but we're going to try and actually make some conditions for it. So what we have got here is lovely. Pen does not seem to work. No, we're back in business. So what we have got here is, so we've got that original equation, which is 2D plus 5. And we're going to multiply it with 101 minus 3D. Now this is equal to K, right? So we got to find three conditions for K so that we're going to get a possible turnover for a given day. So I guess what we're going to do is we're going to do exactly what we did before to try and get the two solutions for D. But in this case, we're not going to find D because K is a constant, and so we're going to have to try and figure this out. So we're going to expand it as usual. So what we've got here is, I think we already expanded it before. I'm just going to copy that because really don't want to be doing this again. So negative 6D squared plus 187D plus 505 equals to K. Okay, there we go. Now what I'm going to do is bring the K to the left-hand side, plus 505 minus K, and then this is equal to 0. So at this point, I need to use the quadratic formula. All right, so I'm going to use the quadratic formula where A is equal to minus 6, B is equal to 187, and C is equal to 505 minus K. So I can say D is equal to negative B, which is negative 187, plus or minus, I've got B squared, which is 187 squared, minus 4 times A, which is negative 6, times C, which is 505 minus K. And that whole thing is now divided by 2 times negative 6, which is also 8. So simplifying this, I've got negative 187 plus or minus. Whew, that is a very ugly equation, but you know what? This is just part and parcel of the game. So we've got 187 squared, which is 34969. What do we got? Plus 24 times 505 minus K. That whole thing divided by negative 12. Because there's two negatives there, I'm going to get rid of the negative. I'm talking about this and this. So what I'm left over with is 187 plus or minus square root of 34969. And I've got 24 times 505 plus 1,220 minus 24K divided by 12. Still going. D is equal to 187 plus or minus. I've got 34969 plus 12120, 478. 478.9 minus 24K, and that whole thing is now 12. Okay, so here's where we start kind of working around it. All right, now the first thing is that we know that the discriminant is inside here. All right, and we also know that the discriminant has to be a positive value. So because the discriminant has to be positive value, so I'm going to write this down first. Discriminant has to be positive to get two solutions. We can actually say that 47089 minus 24k has to be greater than 0. So rearranging this, we're going to get negative 24k is greater than negative 47089. So k has to be less than 47089 minus divided by negative 24. Now remember, because I'm dividing by a negative number, I have to switch the sign. So I'm going to end up with k is less than 47089 divided by 24, which is 1962.04. So that's my first point. My second point is that discriminant d is a rational number. All right, so if d is a rational number, then the bracket, whatever the discriminant, like the 47089 minus 24k, has to be a square number. So for d to be a rational number, 47089 minus 24k has to be a square number. Because remember that we're not looking for like decimals or anything like that. It has to be like a perfect number. And the other one is like d is an integer as well. And if it's an integer, then we have to say that 187 plus or minus square root of 47089 minus 24k has to be divisible by 12. That's the next point. And then finally, we also know that d is positive, because you can't actually have a negative value. So we have to say that 187 plus or minus square root of 47089 minus 24k has to be positive as well. Because when we do a big positive number divided by 12, we're still going to get a positive number. So yeah, so it's got a little bit more of explanations that you have to do. And by the looks of it, I know they're saying 3 conditions, right? But then 3 conditions for all must be opposite. But then in the answer, it actually says make 2 of the listed conclusions. So making 2 of them could get you, so 2 of these gets you an E8, 1 of you gets you an E7. Simplified expression for D gets you a merit. Rearrangement and equal to set to 0 gets you an achieved. Yeah, so it's a really weird kind of paper, this one. There's like a lot of explanation questions, especially with looking at these double excellence questions, which is kind of a bit of over the top, if you ask me. But hey, it is what it is. Cool, guys. That's basically it for this question 3 here. So as always, as I give this advice to people, is that with these types of exam papers, like, do not leave any questions empty. Just try and attempt as much of the paper as you can. It's really weird because like sometimes you get like achieved from really doing some really minor things. So those really complicated questions, even if they look complicated, have a go at them, attempt to try and set up the question, because sometimes it ends up getting achieved or a merit for that. And yeah, and if possible, try and use the graphics calculator where you can, because it does save a bit of time. And I know sometimes made a couple of mistakes in this, apologize. Probably will make more mistakes as I stop, as I kind of not do these papers as much. But hey, look, that's basically it. As I said, good luck for your exam. Some kind of outro should be popping up soon. Thanks for watching, guys. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.